Try baking 500 pounds of pizza in a standard commercial kitchen. You multiply your base recipe by 100, load up the mixers, and immediately the environment collapses into chaos. Scaling a recipe by a factor of 100 does not scale the food linearly. It breaks the physics of the cooking process. A standard mixer safely folds a few pounds of dough, but forcing industrial volumes through standard equipment generates enough friction heat to prematurely activate the yeast. Your timeline crumbles along with the ingredients. Because conventional ovens can only process a few pies at a time, the first batches you pull out turn into cold, soggy waste long before the final batches are even shaped. Baking at a massive scale leaves the realm of culinary art. It becomes a high-stakes problem of industrial manufacturing and supply chain logistics. Large-scale producers manage this volume using the profit-driven pizza kitchen planning framework. This system treats a kitchen like a factory floor, engineering a continuous, optimized flow from raw material to dispatch. This diagram illustrates an industrial dough divider. Maintaining consistent dough structure across hundreds of pounds requires precise mechanical intervention over human hands. Automated servo control systems manage the machinery, monitoring exact output weights and accelerating changeovers to prevent the dough from bottlenecking. The math of the raw materials requires equal precision. 500 pounds of pizza requires generating over 800 fluid ounces of sauce, which means operators must calculate exact water additions to maintain chemical consistency across the entire liquid volume. The cheese introduces another chemical variable. Producers must balance the moisture content and aging times of the dairy so it achieves the exact same melting speed and stretch across hundreds of pounds simultaneously. This diagram shows the system's production line sequencing. The automated belts synchronize the speed of the moving dough with the exact positioning of the baking tins, loading the pans without crushing the fragile product. Commercial scale requires removing human error from the equation. Constant forward momentum is only achieved through automated load balancing. Pulling the pizza out of the oven introduces the final, most critical bottleneck: thermodynamics. Once cooked, the pizza immediately begins losing heat while generating destructive steam. Industrial operations solve this by utilizing low-temperature hold ovens. They calibrate these units to exactly 93 degrees Celsius, creating an ambient temperature that holds the heat without continuing the bake. Lacking industrial hardware, you can engineer a makeshift warming chamber. Place heavy, preheated masonry bricks at the bottom of a hard-shell cooler. A raised platform holds pizza boxes above them. These thermal masses emit radiant heat to maintain internal temperature without scorching the boxes. But trapping this heat introduces a paradox. A tightly sealed environment traps the evaporated moisture, forcing water vapor directly back into the crust. The solution is a strict venting protocol. Operators enforce a strict 2 to 3 minute cooling period immediately out of the oven, allowing the initial rush of surface moisture to evaporate. For transport, loose tenting with aluminum foil reflects infrared heat back downward toward the food, while intentional side gaps provide an escape route for the remaining water vapor. Keeping bulk food palatable requires precise management of the retention and evaporation of thermal energy. Master the thermal management and the workflow logistics, and your 500-pound challenge ends with a continuous output of perfectly browned, hot pizzas. This chart compares our 500-pound benchmark to the absolute extreme limits of pizza engineering. At the Guinness World Record scale, half a ton of food is a rounding error. In 2012, a team in Italy baked a pie named Octavia. They processed 5,000 separate batches of dough over a continuous 48-hour operational window, yielding a single pizza weighing over 51,000 pounds. A decade later, YouTuber Airrack pushed the spatial logistics to their absolute limit. He assembled a single pizza covering nearly 14,000 square feet across the floor of the Los Angeles Convention Center. To fill that physical footprint, his team managed over 13,000 pounds of dough and manually placed over 630,000 individual pieces of pepperoni. Every hot, crispy pizza delivered to a door represents a hidden, everyday triumph of industrial automation, thermal engineering, and supply chain logistics.